In today's conversation, I'm going to address two common criticisms of modern corn production, that of increased nitrogen fertilizer dependency and decreased nutritional quality. There are legitimate societal concerns about hypoxia in the Gulf of Mexico, algal blooms in the Great Lakes, but the central question we'll address today is, should society be increasingly alarmed as corn yields increase? The first criticism is essentially one of increased dependency on more and more nitrogen fertilizers, which are admittedly polluting when they escape into the environment. The National Geographic estimated that as much as 50% of the nitrogen fertilizer applied to all cereal crops were escaping into the environment. And so this has also been estimated from the U.S. as a whole, where nitrogen losses are estimated from the crop producing regions using EPIC models, and these have suggested that large areas of the Corn Belt are essentially experiencing nitrogen losses of 36 to 72 pounds of total nitrogen per acre. When you multiply that by 91 million acres that we grow annually, it definitely raises concern. However, it is also true that nitrogen application rates for U.S. corn have plateaued since 1980. While there was an increase in rates in the 60s and 70s, for the last 3 decades or more, there's been little increase in the actual nitrogen rates applied. And this is occurring in the context of increasing yields. Yields have essentially doubled from 1970 to the present, and this must mean that corn is producing more yield with less nitrogen requirement per unit of yield. The question is this coming from hybrids themselves, or is it coming from the associated management? To address the hybrid question, we analyzed in our laboratory the results of studies that have been conducted all around the world where the grain yield response to nitrogen was measured, but where at the same time whole plant nitrogen uptake by the corn plant was measured in order to look at the overall nutrient uptake and its efficiency. Hybrids were divided into old era hybrids, those were before 1990, and new era hybrids, and those were the ones after 1990. And essentially, we had the fortitude of having this comparison possible with an overall average rate of nitrogen that was quite similar. And we had the fortitude of doing so in a context where the average yield of the modern hybrids exceeded that of the older era hybrids by approximately 2 tons per hectare. What is of most note from an efficiency point of view is that the internal efficiency, in other words, how much grain is produced per unit of nitrogen captured by the corn plant, had improved to 56 from 49.7 in the old era. This is occurring in the context of a small decline in the grain nitrogen concentration at the end of the season. But it's also of note to know that corn plants continue to take up nitrogen during the grain filling period, and in fact, it is very important to note that modern era hybrids take up as much as 30 or 40% of their nitrogen in the post-flowering period. That new nitrogen uptake helps to reduce the problem of reactive nitrogen escaping into the environment during the months of July, August, and September. When farmers have to consider how much nitrogen fertilizer to apply, they are increasingly using the principles of 4R nutrient management in order to achieve a higher degree of stewardship. The 4R principles are right source, right rate, right time, and right place. And this is resulting in a decision framework of farmers with crop consultants that considers not just the economic, but the environmental aspect as well. And of most heartening to me is the fact that corn nitrogen timing has improved in recent years so that the timing of the nitrogen is more in synchrony with the nitrogen requirement by the corn plant. And so there's a gradual shift in the U.S. Corn Belt away from only applying the nitrogen before plant to applying the nitrogen at plant, as well as during early side dress, and increasingly, because of the advent of high clearance equipment, the opportunity is to apply nitrogen late in the season, even when it's above your head height. And so this has associated with it a real opportunity to improve nitrogen recovery efficiency. And nitrogen recovery efficiency is simply known as the relative gain in nitrogen uptake that is gained when fertilizer is applied compared to a side-by-side situation where the same plants receive, same hybrids receive no nitrogen fertilizer. And this is expressed then as a fraction of the total nitrogen applied. So increasingly in our lab at Purdue University, we're studying nitrogen recovery efficiency of the whole system. And in recent studies, we have looked at the timing issue with a wide range of hybrids. In that study, we're comparing control nitrogen with no nitrogen applied as our base and comparing it to a situation where all 220 kilograms were applied at the early side dress stage relative to the application of 165 units at the early side dress time, followed by another 55 kilograms at the late side dress time. We investigated this phenomenon for 7 different hybrids representing a 70-year period of crop improvement by Pioneer. And it is, of course, important to realize that grain yields continued to increase with modern hybrids as expected. The rate of the yield gain was faster with nitrogen than without nitrogen, but it is nevertheless heartening to notice how much improvement in yields there was even without any nitrogen applied in the modern hybrids. But what is of most concern today is the recovery of the nitrogen fertilizer that was applied. Because we had the control plots, we were able to estimate what fraction of the nitrogen fertilizer applied was captured by the corn plants. And whether we had the single timing or the split timing, the results are encouraging in the sense that there is a continued improvement in nitrogen recovery efficiency with more recent hybrids. And that's allowed us to achieve our temporary goal of approximately 60 or 70% nitrogen recovery efficiency so that there is less to be lost to the environment. Not all of this recovery is reflected here because roots were not counted. Now I will address the second criticism that the pursuit of higher corn grain yields will necessarily result in a reduction in nutritional quality of the grain. This concern was addressed in a recent study conducted at Purdue using DeKalb era hybrids over a 38-year period. In that study, we examined hybrids from 1967 to 2005 for their yield performance in response to nitrogen. And again, as expected, modern hybrids yielded better at both the lower as well as at the higher nitrogen rate. What is of concern today is what happened with the macronutrient concentrations as well as the micronutrient concentrations. And with respect to the macronutrient concentrations first, we observed that there was no significant change in nitrogen, in potassium, in phosphorus, and in sulfur over that 38-year period. When it came to micronutrients, our findings again were similar in the sense that for 3 of the micronutrients examined, they included zinc and manganese and copper. There was absolutely no change over time or dilution in these micronutrients. However, there was a small decline in iron concentrations that we noted and that we will investigate further. This particular study with these hybrids planted side by side was done in response to 2 management variables, one being nitrogen, the other being plant density. When it came to the nitrogen variable, first of all, it was interesting to note that the corn grain yields overall of those 8 hybrids for that 38-year period improved 2 tons per hectare, and that, as expected, a nitrogen concentration increase occurred in the grain itself. There was a small reduction in potassium concentration in the grain, and on the micronutrient side there were gains in concentration both from manganese as well as from copper. So there is no summary conclusion about nitrogen increasing or decreasing. It is macro and micronutrient specific. Similarly, these hybrids were planted under a range of 3 plant densities, and although the highest density resulted in a yield decline, there was a small reduction in nitrogen concentration at the highest plant density. This plant density is above rates that would currently be used in the majority of the Corn Belt. It is also of concern that there was some reduction in phosphorus concentration as well as zinc concentration when we went to the highest plant density. Copper, though, increased in its concentration at the highest plant density. We also studied grain nutrient concentrations in nitrogen response trials with 6 food corn hybrids in Kenya. And again, in that study, we had a range of nitrogen rates and only showed 2 today, where essentially there was, as expected, an increase in the grain nutrient nitrogen concentration, but also a gain was noted in phosphorus as well as in copper. And in terms of declines in concentration, there were declines noted in potassium, just as we had noticed in the U.S. study, and in this particular case there were reductions in zinc and manganese as well. So the conclusion is that environment, crop management, nutrient management affect the nutrient concentrations in the corn far more than genetics do. To summarize and address the first criticism, is modern corn production necessarily going to be forever dependent on increased nitrogen? And the answer to that is no. Modern corn hybrids require less nitrogen per unit of yield, and the combination of genetic gains as well as management improvements in the last 30 years have effectively increased the nitrogen fertilizer recovery efficiency of the corn that we grow. Nevertheless, it is true that we should not rest there, but we should continue to pursue both genetics as well as management improvements that will increase that nitrogen recovery further to reduce the chance of loss of reactive nitrogen to the environment, whether to the air or to the water. And to address the second criticism, do increased corn yields from our modern technologies necessarily result in declining nutritional quality? The answer to that is mostly no. Modern corn production technologies have not resulted in a widespread, pervasive, or predictable dilution in nutrient concentration in the grain that can be blamed on yield gains alone. Thank you for listening today.